Hello fellow problem solvers. So today we're going to be doing a problem from the Balkan Math Olympiad 2007 problem number 1. I usually try this geometry problem out for a minimum of 15, ideally 45 minutes, not more than 95 minutes. However, if you'd like to go along with us, give us a go for the next 10 minutes. And now let's begin. Let's first draw the diagram and see what we have here. We have A, B, B, C, C, D. Okay, AC is different from BD. Why it does? We don't know. Maybe there's a case somewhere that we're going to throw away. E is the intersection of diagonals. Prove that AE is ED. Okay, we have an if and only if statement. So let's see. If we draw this like AB, I'll say C somewhere here. And now I'm looking to draw D such that BAD plus ADC. So BAD is somewhere here, plus ADC is 120. Okay, this is actually a good question. How would you draw this point? And for me, the answer is, instead of figuring out like D is on the circle with center, C and radius CB, right, like this. But I need the sum of these two angles to be 120. So when I extend them here, this angle that DC and AB form is going to be 60. So what I'll do is I'll extend AB here and then find my angle of 60, which seems to be something like this. And now I have the point D. And now bam, we need to prove that. So we have this X is X, this is Y and Y. So this is X plus Y. And what does that mean? Well, it means that the sum of these two angles is X plus Y. So now what does the problem statement become? Pause for a few minutes, figure that out. And the answer is, the problem statement becomes, because this plus this plus this plus this is 120. In other words, X plus Y is equal to 60 if and only if AE is equal to ED. Now, how are we going to go about this? Well, there are a couple of ways we can go about this. One way is to say, okay, I'm going to need to have this angle right here will be 60. Let's see, what do I have if this angle is 60? If I take X plus Y is 60, then this is 60, and so is this. This is 60 minus X. Well, what I get is these points are concyclic. And I get this angle is X. This is 60 minus X because of the concyclic points. So Y is 60 minus X. And now I get EA is, say, call this point D, is ET is ED. In other words, I have AE is ED. And so we're done. Now, on the other hand, what if I don't have the angle that's 60? What if I have these two sides which are equal? How do I connect this to the angle? I invite you here, pause for 10 minutes and try to prove the converse. And here's the next step. And if we look at the converse, we see that we don't really have, once we calculate the angles, we don't really have what we had before. Now we have like this plus this needs to be equal to, well, plus this needs to be 180. So we need to have 3x plus 3y is 180. Like that's our condition. That's the thing we need to prove. So now let's say that's more difficult, right? We just don't have the thing we need. Like what do I need to do? I need to prove that this angle right here is equal to X, this angle is Y. You know, how do I get there from this equal to this? And I don't really have much about the triangle ATD. Like I have these points on the sides here. Potentially interesting. This is equal to this. For some reason, this thing isn't equal to this thing. It probably means like X is different from Y. That's what we have. And I think that is there to say that TAD is not a, what's it called? An isosceles triangle. That's really what the condition says. Neither is EBC. Neither is TBC, right? All of these are not isosceles. Why that would be useful? Who knows? But we don't. At this point, we don't. Now the question is, if we're looking at this synthetically, how are we going to do this? And there are a bunch of ideas that you could come up with. Say, okay, maybe if I take the in-center of TBC, there's something interesting. There's something maybe about maybe TI, then like TI would be either BI parallel to EC, CI parallel to PD as well. Maybe TI, maybe if I take the X center, I get something interesting. Say the X center is going to be like, because this is going to be an angle of Y here, and we're going to have an angle of X here because it's an external angle bisector. And now actually this is a bad diagram, bad picture of X and Y. It needs to be more along the lines of here. This is not on the angle bisector, it's this and this, they bisect. And then maybe there's something interesting about this point, the fact that this is, okay, now Y, and then this whole thing is Y minus X, question mark. Wait a second, if this is the external angle bisector, I'm completely wrong. This is like 90 minus Y, and this is 90 minus X. I saw something was off. So both of these are at 90-degree angles. So E is the orthocenter of that. And we have this angle is equal to 90 minus X minus Y. Both of these are 90 minus X minus Y. And this is me, mind you, adding a point and seeing what happens with it. What is this angle? Well, because this is 90 minus Y, 90 minus X. What is that angle going to be? It's going to be 90 minus half of this angle, I believe, if I'm not mistaken. Like, I usually like to draw my general triangle and see like what happens. I know that at I have this is 90 plus alpha half, so this must be 90 minus alpha half. So I have, call this J, I have the angle BJC is going to equal 90 minus half of 90 minus X minus Y, which is equal to X plus Y. So if this angle is going to be X plus Y, it's going to be this angle plus this angle, potentially useful, X plus Y. Now E is the orthocenter. Can I use the fact that E is now my orthocenter, that JE is perpendicular to BC? Well, it's where the potentially, maybe, I have the angle here at the orthocenter is 180 minus X minus Y. Doesn't give me anything special that I didn't already have, that I don't have in a general purpose triangle. Now, is there any way to connect the fact that this orthocenter is equidistant from these 2 points? Like, are AD and like are A and D in any way interesting for this J? Like, do we have that angle? We have this angle right here is going to be, so this is Y, this is not pretty, so this is Y, this must be 90 minus X minus Y. Actually, it's not horrible either. 90 minus X minus Y. This angle, so this is not, this whole thing is then 90 minus X. So this angle is going to be X. Now I have that these 4 points are concyclic. Is there something to that? Is there something we can do with that? I have these are concyclic. These are concyclic. Is there something cool? Does that necessitate these being concyclic? Or maybe a better question yet is, under what conditions does that necessitate that these 4 are concyclic as well? That would be like my question now that I'm asking myself, under what conditions? Though this would, so E and J are not. So these four are not concyclic. We know that to be the case. And there's something we are missing here. I'm going to invite you here to pause for 10 minutes and try to push the problem further. And here's the next step. And the answer is, and I've honestly just noticed this while filming, so this is amazing. I thought this was going to be an idea that was a dead end, but apparently not. So what do we have? We have a couple of things, mind you. So first and foremost, let's look at what is this, like BJ is, we know, perpendicular to AC. But BA is BC. So JC is JA. So we have this. And similarly, JB is JD. JB is JD. JA is JC. We could have also figured this out from the congruence, given we have the angles JDC is equal to JEA is JBA. We'd have this angle is also equal to this one. And we would have a similarity, but given BA is CD, we would have congruency. And from the congruency now, what does this give us? Mind you, J is the X circle of the triangle TBC. What do we have from that? Well, we have this is the X circle, which means these angles are both 90 minus X minus Y. But we also have JA is JC. Now one of two things is then true. Either, one of two things is true. Either TA is TC, or we have by dilemma on the angle bisector and the side bisector, they meet on the circumcircle. How you prove this is by intersecting the angle bisector with the circumcircle and then getting, just like from concyclic points, that this angle is equal to this one, because they're both equal to half of this angle. And now with that, we have that JATC needs to be concyclic because this is the angle bisector. Why is TC not equal to TA? I am just going to say, because they cannot be, because this is X and X, we would have 2Y plus X is equal to X. In other words, Y is equal to 0. That's not the case. So now we have these are also concyclic. JATC, JDTB. We have this is true as well. And now does this give us anything else? Any other way now that we can use the fact about this? We've still really, if we're being perfectly honest, we've still not used the fact this E, which is slowly dying, can't be seen. We've still not used really the fact that EA is ED. Right? We still need to use that fact somehow. And here, I invite you to pause for another 10 minutes and try to push the problem further. And here's the next step. Let me clear this up, make this nicer. Now, what do we have? We have that JA is JC, right? And JB is equal to JD. Now, we've still not, mind you, we would have this even without the angle like EAD is EDA, right? We would still have the same thing. So now we need to figure out how to combine J with this angle, with this condition that EA is ED. And what we have is, from JA is JC, we get that the angle JAC needs to be equal to the angle JCA. The angle JCA, when we calculated, is equal to 90 minus X minus Y. Now JAC, so mind you, when X plus Y is 60, what do we have? Then this angle right here is 30. It's equal to this angle. So J should be on the side AD, if this is the case. Well, let's assume it's not. And let's get to a contradiction with that. So what would we have if it's not? Well, we'd have that this angle now, JAC, would need to be equal. So let's say J is outside. And then we'd have the angle JAC is equal to 90 minus X minus Y, but the angle JAC is JAD plus the angle DAC. or it's equal to x plus y over 2. So the angle JAD is equal to 90 minus 3 halves of x plus y over 2. And we get the same thing on the other side, right? So now what does this imply? Well, it implies that JA is equal to JD because we'll get the same angle here. If on the other hand, what do we have? If 90 minus, if J was inside EAD, we would still have the angle, it would be different, but we would have the same thing. If J was here, say, I'm making up a point now here, and we have this is equal to this, we'd get this angle is equal to this one. We'd get that on both sides, and we'd have that this internal angle is the same. So whatever happens, we get JA is JD. But I've already stated that this means that JA is equal to JD, is JB is JC, which means what? That means J is the circumcenter of A, B, C, D, which means these are concyclic, which would mean by power of point that EC times EA, ED times EB, EC is equal to EB. In other words, AC is equal to BD, a contradiction. However, so this implies that J must in fact be over here. It must be on this side. But if it's on the side AD, then the angle here, 90 minus 3 halves of x plus y, must be 0. Or in other words, we must have x plus y over 2 is equal to 90 minus x minus y. What does that give us? It gives us x plus y, 3 over 2 is equal to 90, or 3x plus y is 180, x plus y is 60, which is what we needed to prove. Like this now gives us BAD plus CDA is 120. And that's the solution. I'm so excited about the solution. Now we're going to show you the trigonometric solution, which does not require this amount of creativity. There are other solutions we could have come up with. There's a solution to reflect C over AD. And the idea there is you want to try, when you're looking for synthetic solutions, you're trying to construct parallelograms, reflecting sides over these things to get more angles. Here, the reason it makes some sense, I think it makes more sense to reflect C over the midpoint here, because then you have I'll first say, like, if you reflect C over the midpoint of AD, which we just saw as J, what you get is, if you get a point here called C prime, to me this makes more sense because I get this is equal to this is equal to this immediately, and I get an angle bisector here. I get AD is the angle bisector of this, I get this is equal to this, and so I know I can use my lemma. And in fact, I can use this lemma. And it's a very common lemma. If you didn't see my video on the lemma, check it out, but it's just proving this. And I think it's a useful thing to have in the back of your mind because this can hide points well. Can hide concyclic points well. So here we would have this is equal to this is the angle bisector. And so either CD, C prime D is BD, which is impossible because C prime D is CA, and CA is different from BD. So that means that these 4 points are concyclic. And now I believe it's just an angle chase. Now this angle over here is equal to this angle over here. So the sum of these two angles is 180. And when you sum them up, I mean, we can also say if the sum of these two angles is 180, then the sum of these 4 angles is 180. And those are x, y, x plus y, and x plus y. So you get 3x plus 3y is 180, x plus y is 60. Now, there's a trigonometric solution as well, which is much shorter. And it's just saying, okay, I have this quad here. Let me just label my angles x and y. and let me see what I have. So if x plus y is 60, let me do this as 60 minus x, 60 minus x. I mean, you need to figure out that you'll get a 60 here. I'll get a 60, I'll get a, b, c, d. I need to prove that ED is EA. Let me calculate that trigonometrically. I have CD is AB. So I'll do AE is equal to what? Sine over, so sine of 60 plus x over, let me use x plus over sine of 60 times AB, and ED is equal to sine of, now 60 minus x plus 60, 120 minus x over sine of 60 times CD. And given this is equal to this is equal to this, these two things are equal, we have AE is ED. If, on the other hand, you had EA is equal to, what's it called, ED, you would have, mind you, EA is ED, this is equal to this. And now you just go from the sine, from the sines on these two triangles. Mind you, have this angle x plus y on both sides. That's why you do it. You would get that we have, so ED over DC is equal to what? ED opposite ED is going to be 2y plus x, sine of this, over sine of, what's it called? Over this sine of x plus y. And on the other hand, AE over AB is going to be sine of 2x plus y over sine of x plus y. This is equal to this because AB is DC, ED is AE. Sines of x plus y cancel out, and we're left with sine of 2x plus y is equal to sine of 2y plus x. If these two were equal, then we'd have x equals y, but that would imply that EC is EB, which would imply that BD is AC, a contradiction. So they're not equal, so their sum is 180, which gives us x plus y 60, what we needed to prove. It's quicker, but less beautiful. And that's, I think, some of the trade-off. I think it's good to know both a trig solution if you really, really need it, but also trying out synthetic solutions, I think, is just cooler. And sometimes, I mean, especially at the harder levels, it's more about your synthetic solutions. It's more about having synthetic solutions, adding points which are very hard to prove trigonometrically, or for some computational methods. Like that's usually the types of problems that come up on higher levels, but they could still potentially be solved via these computational methods as well. I think this was a cool problem. I didn't see this solution before. This is so nice. I'm very happy I made this problem now because I found a different solution. So this finishes up our problem, and as always, thanks for problem solving.